Hey guys, how are you? I hope you will be doing fine and your day was going good because we are just ending the day with this brand new session that I have started from today. And from today, I'm gonna take your chemistry part, and I'm gonna start with the mole concept first. So let me just check my voice first. So let me just check my voice. So yeah, everything is everything is. Okay, so everything is going fine and my voice is very clear. So I hope you must be enjoying the day and welcome to Let's Crack JEE channel, guys. Let's Crack JEE English channel actually. So let's begin. So this is me, guys. My name is Komal Jain and I have done masters in chemistry from IIT Guwahati, and I was one of the topper of IIT Guwahati, as well as I have done BSc honors chemistry from Gargi College, Delhi University. I was second topper of Gargi College, and I have also worked in IIT Guwahati as an academic initiative team member. With that, I have cleared many national level entrance exam. For example, I have cleared lecturership exam with 31 all over India rank, GATE with 330 all over India rank, IIT JAM 165 all over India rank. Uh, with that, I have also cleared AIEEE and IP medical exam. So if I can do, then you can do. Yeah, that's what I follow. Miracle is nothing but it is just another name of effort, guys. So this is the India's biggest platform with on which I'm teaching you guys, and this is my schedule. Like, you can follow me for the special classes at 8 a.m. On Monday, Wednesday, and Friday, and the class duration will be 1 hour, where we are covering the full MS John book organic chemistry. But let me tell you, there the class will not be totally English, but it will be Hindi plus English. And as well as I'm taking the YouTube classes on Let's Crack JEE channel as well, where I'm teaching salt analysis. And yesterday I have started with the cations part, and when it will be over, like cation part will be over or salt analysis will be over, then I will start with the organic chemistry track from from very basic to the advanced level. And YouTube English channel, I am doing mole concept. This is my first lecture, and we will be taking, like, I will be taking your class on Monday, Wednesday, and Friday at 10 p.m, guys. But on Wednesday there will be no class. This Wednesday there will be no class, but the Wednesday class will be happen on Sunday. Okay, this Wednesday, for this Wednesday only. So this is my capsule course on all reactions of organic chemistry. If you want to follow me, you can also follow me on Plus, where I have launched my course. This is my first course where I am, I'm giving notes for all the reactions. Like, your 2 months time will be saved by me, by my notes, where you can directly follow my notes for all the reactions. Okay, so guys, this is my Plus schedule. Every day I come live at 7 p.m on Plus, but on Wednesday I will be coming live on 9 p.m, but other classes will be held on 9 p.m. You can see here, one is 9 p.m, but and the other are on 7 p.m or at 7 p.m. Okay, so guys, this is the first lecture. We are doing this for JEE 222 2022, because you already know that 2021 is already there, so we can't cover up whole course in just 2 or 3 months. So I'm doing this, I'm taking these lectures because for JEE 2022. Oh, someone is watching me. So guys, the very first question which come in the mind when we start learning chemistry, the very first question come in the mind is, what is chemistry? What is chemistry? Like, I think you have already studied that in the previous classes, in the 8th class, in the 9th class. Ki what is chemistry? What do you mean by the chemistry word? It is not just a mystery of element jo uh, that everyone say, but it is just a science of molecules and their transformations. Like, we will study the molecules here and their transformation, like how they are converted to one form to the another form, how they are forming the different kind of compounds, So it is a science not so much of the 100 elements, but of many infinite variety of the molecules. Like we will not study only the elements, we will not study sodium, chlorine, oxygen. We will study their compounds also, like sodium oxide, that is formed by sodium and oxygen when we mix, when when we react sodium and oxygen together, so they form the sodium oxide. Just like that, we have infinite number of compounds. Okay guys, so uh, yeah, that may be built from them. Just like you have the alphabets, you have 26 alphabets, but when you go for the sentences, when you go for the words, when there are infinite number of words, infinite number of sentences you can frame from that. Similarly, we have limited number of elements, but compounds are infinite, and the chemistry of those compounds we will study in the chemistry. Okay, and this is said by the Ronald Hoffman. So guys, for the sake of convenience, अपनी convenience के लिए, for the sake of the convenience, we have divided this science, जो whole science है, we have divided this science into into different categories, in different disciplines. Different disciplines like chemistry, physics, biology, geology, etc. So, the branch of science that studies the preparation, properties, structure, reactions of the material substances is called chemistry. Like in chemistry, what we study, it is the branch of science in which we study the preparation, like how we prepare different compounds, what are the different properties, like magnetic property, reaction, how they show the reaction. So, there are different properties, what are their structures, reactions, what kind of reaction they show, will they react with the oxygen, will they react with the hydrogen, will they react with the chlorine, that we will study in the chemistry. Now let's talk about the importance of chemistry. Like I am teaching you the chemistry, I'm teaching you the chemistry, so what is the need of that? Without that, can we survive? Can we survive without without learning chemistry or without knowing chemistry? We can't, because chemistry is everywhere. Chemistry is everywhere around you. Even in your daily life, you do many things related to the chemical reactions. For example, if you are making a tea, then you are using the concept of your boiling point, because milk boil at some temperature, or you are like you are washing your clothes, then also you are using soaps. So soaps perform their action and clean your clothes. This is a kind of chemical reaction is there. This is a kind of process is there. So everywhere there is a chemistry. So guys, like for example, weather patterns, that in July there is a summer, in December or November there is a winter. So there are different weathers. So that you study in the chemistry, because there is a temperature difference, na? And there is a functioning of brain, because functioning of brain depend upon various neurotransmitters, and neurotransmitter is nothing but the chemical molecules. Operations of a computer, production in chemical industries, different kinds of compounds is synthesized in the chemical industries. Like for example, pesticides. Pesticides is nothing but it is a chemical compound. Manufacturing fertilizers, alkalis, acids, salt, dyes, polymers, drugs, soaps, detergent, metals, alloys, etc. So you see that there is lot of chemistry. There is a lot of chemistry everywhere. In any substance, you can easily see the chemistry. And if I say drugs means not wo drugs, heroin, ganja nahi, but it is a kind of drug that act, that perform the biological reactions in your body, that is helpful for your body. Or if you take that drug in in a huge amount, and then that become poisonous for your body. So drugs in the small amount act as a medicine for your body. Okay? And in these drugs we can study about cisplatin, Taxol, AZT. AZT is azithromycin, that is AIDS, that is used for the AIDS. Cisplatin and Taxol is used for the cancer therapy. You can easily see this is cisplatin, how it is cell in the bottles, and this is a DNA. In between of that cisplatin is present. So what is cisplatin is doing? If there is a two strands of DNA, you know DNA is a double stranded molecule. So if there is a two strand, then this cisplatin fix in between of the DNA and separate the two. Like this cisplatin do the unfolding of the DNA. So that's how our cancer cells, you know, stop growing, and that's how the tumor is curated. Now also there are many like materials in which many different properties can be studied easily from the chemistry, like magnetic, electrical, optical properties. So let's talk about the matter. Now this girl is taking the selfie. So selfie, how she's taking? She's using a mobile. Mobile is nothing but a form of matter. A form of matter, or you can say it is a solid. Solid is a form of matter. So anything which has a mass, which has a mass, occupies space, is called matter. For example, this is a bottle. This has some mass. I can weigh this. How much gram this bottle has, and this occupies a space. Some part is occupied by this bottle, no? Of the space. So that's why this is called the matter. So everything around us, for example, book, pen, pencil, water, air, all living beings are composed of matter, because we all, you know, takes some space in the whole universe. We are taking some space. If I'm sitting on this chair, then no one can sit over here until and unless I go from here. Okay. So let's talk about the states of matter. How matter is classified into different states. So matter is basically divided into the three categories, that is solid, liquid and gas. So how we will differentiate between these three categories, solid, liquid and gas, how we will differentiate in between these three? We can easily differentiate between these three according to the property they show. For example, if I'm talking about the shape, then solid has a definite geometrical shape. This has some dimension. Dimension is fixed. Its length is fixed, breadth is fixed, height is fixed. So solid has a definite geometrical shape. Liquid, it has a it does not have any kind of shape. Actually I have mistyped here. Mistyped. Should be indefinite. So liquid has no shape. Liquid has no shape because whatever content I take this water take the shape of that container. So that's why the liquid do not have any kind of shape, indefinite shape. And gas is also as having an indefinite shape, because if there is a gas in this room in which I am sitting, if I take those gas and fill in a bottle, then it can easily fit into this bottle. It can easily fit into this bottle. So it takes the shape of this bottle. Now, because there is a lot of space in between the molecules of the gas, so we can easily fit those molecules in a very small space also. Let's talk about the volume. Let's talk about the volume. Like solid has a definite volume. Solid has a definite volume. You can easily, calculate the volume of a cube. You can easily calculate the volume of cuboid. Liquid. Liquid also have a definite volume. Now, when you go to a milkman, you demand for 1 liter, 1 liter milk. So this is 1 liter is what? 1 liter is a volume, and volume is fixed. You can take any volume. And gas has indefinite volume. It do not have any kind of volume, fixed volume. It do not have any kind of fixed volume. If I talk about the intermolecular space between the particles of the solid, liquid and gas, solid in the solid the particles are tightly packed. They are present very close to each other. So the intermolecular forces are very, very strong. One atom or one element is attracted to the second element very strongly. So very strong bonds. In liquid there is a moderate bonding. In gas there is a weak bonding. If I talk about the density, then solid has a high density. Highest density actually. It has the highest density except water. Because in case of water, the density of liquid water is more than density of, ice, or you can say solid water. How we can say that? Because ice floats on the water, so that's why we can say ice has a less density than the liquid water. Okay. And if I talk about the liquid, it has a moderate density, matlab it has a density in between of gas, in between of solid. It has a moderate density in between of gas and in solid. And gas has a least density. Fluidity is the tendency of a substance to flow. Solid do not flow. Why it does not flow? For example, I've put this bottle here, and I come here after one day. Then where will be this bottle? This bottle will be here only. This will not go over there anywhere. This will not go anywhere. Why? Because it cannot move. This bottle is an example of a solid cannot move, cannot flow. While in case of liquid, like I drop some water here, then after 2-3 minutes I come here, then this liquid will be flowing. This will flow. Gas has a highest fluidity. For example, if you fart somewhere in the corner of your room, then you can easily say ki the whole room will be smelling. The whole room will be smelling because the fart smell go all over the room and spread it. That's why. Rate of diffusion is a tendency of the two substance to mix together. Solid, very slow. Diffusion, liquid, moderate. In gas, it is the highest. You can easily say, because if like in a room, if you take nitrogen and oxygen, then these two mix at the instant. And liquid takes some time to mix. So these are the basic difference between the solid, liquid and gas. There is also two more states of the matter, that is the plasma and Bose-Einstein condensate, but that we will not study here. But I have just told you that we have two different states, that is plasma and Bose-Einstein condensate. So let's talk about the interconversion. Like we have studied the solid, liquid and gas. Now we will study how these are converted from one form to another. Like if I want to convert solid into liquid, if I want to convert liquid into gas, if I want to convert solid into gas, then what should I do? How I will interconvert in between these three states of matter? See, if you want to like convert your solid into liquid, then you have to do the melting. Like you have to increase the temperature of the solid till that instant when it melt, when it form the liquid, when it is converted into the liquid state. For example, water when you take the ice, you increase the temperature, and after some time you find out that that ice will become liquid water, right? So this process is called the melting. And the temperature at which solid melt into the liquid, that point is called, the temperature is called the melting point. Liquid, when we heat the liquid, then at a time, at a temperature, the liquid converted into the gaseous. So this is called the evaporation or boiling. Boiling is a more correct word as compared to evaporation, because evaporation does not need heating, but boiling needs. So boiling is more correct word as compared to evaporation. Similarly, if you want to go reverse, like if you want to convert gas into liquid, then you have to decrease the temperature. You have to cold that thing. So by condensation you can go from gas to liquid. Or if you want to go from liquid to solid, then you can easily do that by solidification. You just have to cool your mixture of liquid, whatever you have taken. So like if you want to convert solid into gas, then what you have to do? You have to do sublimation. You have to increase the temperature till that point where the solid converted into the gas. Similarly, if you want to convert gas into the solid, then you have to do the deposition. Deposition is nothing but it is also called the desublimation, and somewhere in the books it is also called sublimation. Both are correct words, but deposition is the more correct word as compared to sublimation for gas to liquid state. Okay. Okay, let's move on to the next thing, that is the classification of matter. See what we have done, we have talked about the states of matter, we have talked about how we can differentiate in between them, how we can intern convert between them. Now let's talk about the classification of matter, like how we will classify the matter. Now matter is classified into two categories, that is mixture and pure substances. Now how we will come to know that this is a mixture, it is a pure substance? We have to check the composition. If the composition is uniform, then we can easily say that this is a hmm. If the composition is uniform, no, then we can say this is a mixture. Okay. If this composition is uniform, then we can easily say this is a pure substance. Then we check about the mixture is a divided into two categories, that is homogeneous mixture and heterogeneous mixture. Mixture is divided into two categories, homogeneous mixture and heterogeneous mixture. How we will come to know that this is a homogeneous mixture or heterogeneous mixture? We check out the composition. When the composition is uniform, then it is a homogeneous mixture. When the composition is not uniform, then we will say that this is a heterogeneous mixture. Similarly, for the pure substance is divided into two categories, that is element and compound. When it is it is a chemically composed thing, like it has some different things, like it has some different elements like oxygen, nitrogen, different elements it contain, then we can say that this is a compound. Otherwise we will say that this is an element. For example, if we have only sodium elements, then we can say this is an element. We have a oxygen, then we also have the two oxygen atom, so we will say that this is the element. For compound, like we have a water, it composed of oxygen as well as hydrogen, so this is a compound. Heterogeneous mixture is also divided into two categories, that is colloids and suspension, which we will not study here. We will study later on in the class 12 when we will study the surface chemistry, but here we will not cover the colloids and suspension. Okay, so let's talk about the pure substances. What are they? What are the pure substances? See, pure substance sounds very good. Pure that do not contain anything except one thing. Okay, that do not contain anything except one thing. So the constituent particles of the pure substances has a fixed composition. They do not have anything extra, they have one thing only. They have fixed composition. For example, copper, silver, gold, water, glucose are all example of the pure substances. For example, if you take the glass of water, then it only have the molecules of water, it do not have anything. I'm just considering that this is a distilled water, because distilled water do not contain the ions, minerals it do not contain, so it contain only the molecules of the water. So we will say that this is a pure substance. Or if you have taken the block or rod of iron, that this rod will contain only the iron element and not anything. So we will say that only iron is present, so this is a pure substance. Okay, why it is having the fixed composition? Because if you say that if you have a water, then we have, for one oxygen atom we have two hydrogen atom. So we can easily say that whatever molecule of the water you take, every molecule has one oxygen atom and two hydrogen atom. So there is a fixed composition in each molecule or in each compound. Okay, so for example, we have taken the glucose has the formula C6H12O6. It has a formula C6H12O6. So we can say that it has a carbon, a hydrogen and oxygen. So it has a carbon, it has a hydrogen, it has a oxygen. All are in the fixed ratio. Carbon has 6, hydrogen 12 and oxygen 6. So the ratio is 1:2:1. So it will remain the same. Whatever you take the molecule, whichever molecule you take of glucose, it has 6 carbon atom, 12 hydrogen atom, oxygen 6. So we have the fixed composition. Okay, pure substance cannot be separated by the simple physical method. See, if you have like water, if you have a water, then there is a bond in between the water and, sorry, in between the hydrogen and oxygen. There is a bond. There is a covalent bond, right? You have already studied the covalent bonding in the class 10th. There is a covalent bond. So you cannot easily separate this by the physical methods. By the physical method, you can't separate the oxygen and hydrogen. Okay, so pure substance is also classified into two different categories, that is elements and compounds. See, this picture is very good because it explains you everything. See, elements, you can consider the iron block or iron rod, you can easily consider that, in which only the iron element is present. Only the iron element is present, no, nothing is extra, none other element is present. But in the compound, you can see blue dots, you can see blue dots as well as your red dots, red dots. So for each blue dot there is a red dot, for each blue dot there is a red dot. The composition to fix hai, composition is fixed. So we can say if we have a water molecule, then for one oxygen atom we have two hydrogen atom, but the composition is fixed, composition is fixed. So we can say that for every water molecule this is true, this is true, but we have two different type of element, we have oxygen and hydrogen, we have two different different type of element. And when we have two different type of element, then we say that this is a compound, this is a compound, this is not the element. Element have only one type of element, but compound have more than two or more than two different type of elements, but they are present in the fixed ratio. Okay, let's talk about the, okay, ye homogeneous or heterogeneous we will do later on, but let us understand the elements and compounds. So we have studied, now let's talk about the elements in detail, and as well as we will study the compounds in detail also. So we have already studied the particles of the element. Ek second. The particles of the element consist of only one type of atoms, one type of atoms, जैसे sodium, that is Na, copper Cu, silver Ag, hydrogen H2, oxygen O2. O2 also has the one type of element, that is oxygen, that is oxygen. We have two atoms of oxygen, but the element is same, that is oxygen. Okay, see, similarly देखो, only red dots are present, but for the compounds one blue block is present for the one red dot. So fixed composition, both are joined together by a covalent bond, by some kind of bonding to different type of element. Now compounds, let's talk about the compounds in detail. So what is a compound? When two or more substances of different elements combine together in a definite ratio, the molecules of a compound is obtained. So when, like, you have two different elements, for example, like you have hydrogen, you have oxygen, both are element, because both have same type of atoms. These react together and they form the water, okay. So I have typed the, I have typed the balanced chemical equation. So they are reacting together and they forming the compound, but they are combining in a definite ratio, 2:1 ratio. So we can say this is a compound. The constituent of a compound can be separated by the chemical method. So we can easily separate by the chemical method, not the physical method. We can separate that with the chemical method, because we have to break the bond in between the hydrogen and the oxygen. If we want to separate this hydrogen and oxygen, then we have to break this bond, and the bond breaking is possible only when you use the chemical methods. Next, let's talk about the mixture. Like, I'm going very slow because this is for the 2022 and this is not for 2021, so I'm going very, very slow so that you can easily catch up with me. Okay, so tell me guys, who is live right now? Is there anyone live? Okay, so let's talk about the mixture. Okay, so no one want to like message me, right? Let's talk about the mixture. Mixture sounds very good. Mixture, like we are taking two things together, two or more things together, and we are just taking, you know, we are taking two things and taking together, mixing these two things. So that will form a mixture. But we can take any ratio. Like if I'm mixing A and B, then I can take 4 grams of A, I can take 6 gram of B. I can take any composition. No? I can take any composition. Okay. So a mixture contains particles of two or more pure substances which may be present in any ratio. In any ratio. You can take 4 gram, you can take 6 gram, you can take 5 gram, you can take 5 gram. You can take any ratio. Hence their composition is variable. So their composition are variable. So their composition are variable. For example, sugar solution in water, air, tea, etc. Air, why air? Because let's suppose if I'm sitting in this room, then you can say, you can calculate actually ki how much nitrogen is present, how much oxygen is present here. For example, the oxygen, the moles of oxygen are present in this room is, let's suppose 10 to the power 4, and nitrogen moles, let's suppose present here is 10 to the power 5. But is it same for the second room, for the other room? It will be same or different? It will be different, na? Because nitrogen and oxygen making a mixture, this is not making a pure substance. Okay, if I am taking the oxygen and nitrogen together, then this is forming a mixture. Okay. For example, tea also have sugar, you know, milk, water, and tea leaves. So tea is a mixture of all the things. Okay, so in mixture you can take anything in any composition. Like we have taken triangles, we have taken 5 triangles here, we have taken 2 yellow circle here. So we can take in any ratio. Okay, so let's talk about the homogeneous mixture. What is a homogeneous mixture? Homogeneous means same. What is same here? When they're uniform, like we have a mixture and the particles are uniformly distributed throughout the bulk of the mixture. For example, if you are making the salt solution, like if you are making a salt solution, then you can easily taste that solution. Bolo, you can easily taste that. For example, if you have mixed 10 grams of salt in your, let's suppose 100 ml of water, then if you take one spoon and drink that water, that will be tasting same as that of second spoon if you take out. Okay, why this is so? Because salt is uniformly spread in the water, in the bulk of the water, in whole water it is uniformly distributed. So this kind of mixture we called homogeneous mixture. For example, sugar solution, air, so they are homogeneous. See here, we have a pattern here. Yeah, here a pattern is following: to green, green, red, red, green, red, red, green. After every green dot we have two red dot. So there is a pattern. But in heterogeneous, there is not a pattern. The pattern is not there. So the distribution is not uniform. Let's say if you are taking sand and water, then can you say the particles of the sand that you have taken in one spoon will be same the number of particles of sand in the second spoon? No, you can't say. So those kind of mixture are called heterogeneous mixture. So they do not have the uniform composition throughout, and sometimes different components are visible. So you can easily take out that component. You can easily separate those mixture. Like you have taken two or three dry fruits together, then you can easily take out the kaju. You can easily take out the almonds. That's how it seems. That alloy is a homogeneous mixture. Like some books write it as a homogeneous mixture, but many educator comment or over this that it is a heterogeneous mixture. Book comments that it is a homogeneous mixture. In books it is written that it is a homogeneous mixture, but many educators say that this is a heterogeneous mixture. So I think it depends upon the type of alloy which you are forming. Okay, but mostly it is called as homogeneous mixture. Harsha? Okay. So if you want to take out the, if you want to separate the mixture of the components, then we can use the physical methods. We can use hand picking, we can use filtration, crystallization, distillation. We can use any method, any physical method. But to separate the compound, we need a chemical method. For compound, we need a chemical method. For the mixture, we can easily separate by using the physical methods. When can we expect JEE 2021? See, Just Rocket. The name is Just Rocket. So, see, Just Rocket actually JEE 2020 exam is held in September when the corona cases are higher than the April. If that exam held in April, then the corona cases were less. But in the September, the corona cases increased. So that's how I am expecting, because the exam held in the corona time, so it will be in the January only. It will be held in the January, that I am expecting. But yes, it can change. It can change. And there is not any kind of fixed thing we can say about that. But I give you an advice. Please prepare for the JEE 2021 January exam, because if you prepare yourself for the January exam, then if you know exam held in January, then you can easily go there and give your exam effectively. Okay, so we have covered this thing. Now let's talk about the properties of matter. What are the different properties of matter? We have the different properties, that is physical properties and the chemical properties. I think you must have studied this in the class 9th. The physical properties and chemical properties, what are those? Physical properties can be measured or observed without changing the identity of the composition of the substance. Like physical properties are those which can be observed easily, very easily, from the naked eye also. But chemical properties describes the matter potential to undergo some chemical change. Like there is some chemical change, new product is formed. In the case of chemical reactions, chemical properties. In the physical property, there is no new compound is formed. For example, if you are boiling a potato, then it is a chemical change. Okay, if you are boiling a potato, then it is a chemical change. But if you are heating your water and convert it into the steam, then it is a physical change. Because when you decrease the temperature of your steam, then you can easily form the water. So that a kind of physical property. But in the chemical property, new substance is formed. Physical properties in consist of mass, volume, density, melting point, boiling point, color, order, refractive index. These are the physical properties. But if I talk about the chemical property, then reactions. Yes, chemical property sounds like reactions, chemical reactions. It includes acidity, basicity, combustibility. For example, one substance is combustible, another substance is not. Then how can we say that it is combustible or not? We can say that easily based on its chemical property, that it has the property that it can burn, and that property is called the chemical property. Okay, the number of possible chemical bonds. Okay, so next thing is measurement, that the NCRT has given in your book. But JEE perspective, it is not very important. Measurement is not very important. but we have to study. Like there is a scientific approach developing a model. How you develop a model for your studies, for your everything, for your reaction, how you develop a model. First you observe. Like you have mixed A and B, you have mixed something with something, you have mixed the things. You observe, there is a color change, there is a order, there is a gas, what is there, okay? There is a change in state. So you observe something and you make some hypothesis, you make some idea, you make some idea that this will be happen, so this will be happen, so this will be happen. So this kind of hypothesis you make. Then accordingly, according to your hypothesis, you perform another experiment, you perform another experiment, okay? And if that experiment observation matches with your ideas, then you develop a theory, then you develop a theory. Like you give some laws, you give some theories. So based on those theories you do further experiments, further experiments to check the reliability of your theories. Ki is your theory is valid or not, if you have given the correct theory or not. You standardize your theory with many different examples, so that you can be sure, and you can do further, further things. Like if you have developed some chemical compound, then you can easily check what kind of reaction it can show. So that kind of further experiment is there. So this is how you develop a model, a thing. First you synthesize something, then you study the properties of that molecules, and then you study the further reaction it can show, further applications of that molecule, where we can use, where we can use that molecule effectively, in which kind of industry we can use. So that's how it is developed. Okay, so let's talk about the measurement in detail. See, measurement is nothing but a quantitative observation, or measurement is represented by a number. So measurement, I am measuring the volume of the water in this bottle. So it must be like 50 or 100 ml. So there is 100 ml thing. So there is a number, there is a number 100. So it is a number, and ml is unit in which I measure the volume of that liquid. So there is a unit also, there is a number also, which tell you how much water is present in this bottle. This is called the measurement. This is called the measurement. For example, if you are like calculating the length of a room, then if it is a 6 meter, then we can say that 6 is a number and m denotes the meter, which is a unit, which is a unit in which the length of a room or anything is measured. So we have two different system of measurement. First is the English system and second is the metric system. The metric system was originated in France in late 18th century and is more convenient, and it was based on the decimal system. See, in France, metric system was developed and it was very famous, or very convenient, because it has a decimal system, because we can easily calculate the 10.1, 10.2, 10.3. That's how it is. So let's talk about the international system of units, that is SI units. Okay, so let's talk about this thing. Okay, so international system of units, which actually provided the units, which actually provided the basic units to you, and then you have derived the units of different things. Like for example, length, you have a meter. Meter is a basic unit. Area has a unit of meter square. So meter square is developed from meter only. So these basic units is given by nothing but the international system of units. So that is also abbreviated as SI. Was established in 11th General Conference of Weight and Measures, CGPM, from Conference Generally Depois, and ये French, it is written in the French, so I will not be able to give you the meaning of this thing because this is already written in the French, and this meaning is the General Conference on Weight and Measures. So CGPM is the intergovernmental tripartite organization created by the diplomatic treaty known as Meter Convention, which was signed in Paris in 1875. So this is actually the history or nothing else. This is the history, and that IIT JEE never asked. This is just a history. Okay. Okay, so let's talk about the some basic, some physical quantities, some basic quantities and their units. We have in total we have seven base units. Seven base units we have. First is for the length, second is for the mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. For the length, we have meter. For the length, we have meter, and the symbol by which we represent a length, that is L. And unit we use we use only the small m. Like meter is abbreviated as small m. You know that because you are writing from the your sixth class 4 meter. So 4 is a number and m is denoting the meter. Similarly, mass have kilogram. Mass has the unit of kilogram, that is kg. Time, second. Electric current, ampere. Thermodynamic temperature, Kelvin. Amount of a substance, mole, mol. Luminous intensity, candela, that is represented by the small c and small d. Okay, remember that amount of a substance is represented by the unit mole and it is abbreviated as a mol. No e is written here. No e is written here. Okay. So let's talk about the different physical quantities that can be derived from these basic units. See, we have many things that we can derive from these basic physical things. These are just the examples, just the common example you can say, because we are doing experiments, we are calculating many things, and we are deriving the units. For example, area is nothing but length multiplied by length. बोल सकते नहीं बोल सकते? We can easily say that now, length multiplied by length. Even if you multiply length into breadth, then you know that length is a unit of meter. Length is a unit of meter. Length also have a unit of meter. Breadth is also having a unit of meter. So this is nothing but meter square, that is derived from this meter. Similarly, we have volume. Volume is nothing but meter cube. Density is nothing but mass by volume. Mass by volume. Mass has a unit of kilogram and volume has a unit of meter cube. So we can easily say kilogram per meter cube. Similarly, other units can be derived. Other units can be derived. Okay. Now let's talk about some prefixes. Some prefixes. See, without like before going and understanding these prefixes, let me talk about that one example. For example, if you are going to the market and you want to you want to buy some haldi or turmeric, you want to buy some turmeric, and you are saying to the shopkeeper that please give me turmeric 0.001 kilograms. You are demanding the turmeric as 0.001 kilogram, and you are also going to a shopkeeper for the atta, and you are saying please give me 5 kg atta. Then which sounds cool to you? I think 5 kg sounds cool to you, and turmeric 0.001 is not sounds good. Even the shopkeeper will say, what you are saying, yeah, what you are saying, 0.001 kilogram, what is this? So if you has said 1 gram, then this sounds good rather than 0.001 kilogram. So we have changed those things. We have changed this k, or we have deleted this k, and we have written only the gram here. So this is the meaning of prefixes. We use the prefixes so that our number looks good, sounds good. Okay. So these are the different your prefixes. Different prefixes. For example, 10 raised to the power 24 yotta meter. Sorry. sorry, let me talk about how I have written this thing. 1 iota meter is nothing but 10 raised to the power 24 meter. So iota is actually representing 10 raised to the power 24. Similarly, if I'm writing 1 femtometer, 1 femtometer, then it is representing 10 raised to the minus 15 meter. So this is the meaning of F here. Okay, you have to remember this table for your exam because that's very important. That makes a basic of your physical chemistry. If you don't know the prefixes, then there are many things that you can't do, similarly. Here I have taken the base units as F, base unit as m, meter I have taken the base unit as meter, and this is the prefixes, similarly if I take like if I take picoampere, 1 picoampere, then this will be equal to 10 to the minus 10 ampere. So pico means nothing but 10 to the minus 10. If I am taking 1 milligram, then it is nothing but equal to 10 to the minus 3 grams. Okay, 10 to the minus 3 grams. So this is the meaning of the prefixes. Okay, so that you have to remember, you have to written those things, then you can easily calculate, you can easily check out ki you are doing good, you are doing correct or not. So this is the question for you guys. Let's see ki aap you can do or not. Just answer me in the comment box. Answer me in the comment box. This is first, this is second, and this is third. Please give me the answer in the comment box. Yeah, Harsha, I will take the molarity as well as normality, but that will take time because this is just a first lecture and I am covering everything for your board exam. For your board kya 11 in 11 there is no board, but yes, for your 11th exam and for your JEE exam I am covering everything. So give me the answer in the comment box. We have just studied this thing now. So just take a screenshot of this question and give me the answer. Okay, for your benefit I am writing over here 20 meter is how much nanometer, and that's equals to how many gigameter. Tell me the answer. What should I fill in this dash? Tell me. Okay, the time is over. I am giving you the answer for this. See, nanometer is over here now, so I will find out the nanometer. Where is it? Where it is written? It is written here. So I know 1 nanometer is nothing but equal to 10 raised to the minus 9 meter. 1 nanometer is nothing but equal to 10 raised to the minus 9 meter. Now I have given how 20 meter is how much nanometer. So I will first find out 1 meter is nothing but 10 raised to the 9 meter. So I have taken 1 meter here and then 10 raised to the minus 9 will go over here in the denominator. Okay, pura I will do complete. I'll give you the complete solution for that. See, I know 1 nanometer is nothing but equals to 10 to the minus 9 meter. So we have 1 meter is nothing but equals to 1 upon me 10 to the minus 9 nanometer. That is nothing but equals to 1 meter is equals to 10 to the 9 meter. Now I know 1 meter is 10 to the 9 meter, 10 to the 9 meter. So how much 20 meter? 20 meter is 10 raised to the power 9 multiply by 20. So that makes 2 into 10 to the 10 meter. Okay, so I will fill here 2 into 10 to the 10 nanometer. Okay, so I got the answer. Now it is asking ki 20 meter is how much gigameter. So let's search for the gigameter here in the table. So here it is written, here it is written. So I can say 1 gigameter is equals to 10 to the 9 meter. So 1 meter will be equals to 10 to the minus 9 gigameter. So 20 meter will be equals to 10 raised to the power minus 9 multiplied by 20. So I got the answer 20 multiplied by 10 to the minus 9. So that will be the answer. That's how you have to calculate. You have to calculate how much is this, how much is this. Try to convert everything into the base unit first. Like if you have nanometer, then try to convert it into the meter, then you calculate the other thing. This is the method to solve these kind of questions. Now next question is, how much 1 micrometer is equals to kilometer and kilometer is equals to decimeter. Let's do this question. See, 1 micrometer is nothing but equal to 10 to the minus 6 meter. You can see it from the table. This is micro. So we have 1 micrometer is equals to 10 to the minus 6 meter. Also, I know 1 kilometer is equals to 10 raised to the power 3 meter. 10 raised to the power 3 meter. Okay. Now I have to calculate 1 micrometer is equals to how much meter. How much meter. Okay. How much meter. Now let's convert into the standard unit, that is meter, base unit. So 1 meter is equals to 10 raised to the power minus 3 kilometer. I can write now. I can write. Now I will put this meter, the value of meter over here. So 10 raised to the power minus 6 multiplied by 10 to the minus 3 kilometer. So I will get 10 to the minus 9 kilometer. So the answer will be 10 to the minus 9 kilometer. Okay. Now let's talk about how much 1 micrometer is equals to 1 decimeter. So decimeter, this is a decimeter. This is a decimeter. Now I know 1 decimeter is equals to 10 to the minus 1 meter. So we have 1 meter is equals to 10 decimeter. That I can say now 1 meter is equals to 10 decimeter. So if I put in this equation 1 micrometer, that is equals to 10 to the minus 6 meter. If I put the value of meter from here, that is 10 decimeter, then that comes out to be 10 to the minus 5 decimeter. So the answer will be 10 to the minus 5 decimeter. Okay. Similarly, we can easily calculate this. For this, we have to know what is meter, what is centimeter, what is the relation between them. So see, centimeter is written over here. So I can write 1 centimeter is equals to 10 to the minus 2 meter. See over here, 10 to the minus 2. So 10 to the minus 2 meter, or 1 meter is equals to 10 raised power 2 centimeter. Now how will 1 meter cube? 1 meter cube will be equals to 10 to the 2 centimeter cube, and that's come out to be 10 to the 6 centimeter cube. 2 multiplied by 3, that is 6. 10 to the 6 centimeter cube. I think this is not written, like this is not visible to you because I'm coming over here, so I'm going like this. I think that is visible now. Yeah, I think that's visible, right? So we have 10 raised power 6 over here. Okay. Now let's talk about the things. Here we got 10 to the power 6. Now let's talk about how much centimeter cube is equals to 1 ml or liter. See that you have to remember 1 centimeter cube is always equals to 1 ml. Remember this thing for your exam. Remember this thing. So 10 raised power 6 centimeter cube will be equals to 10 to power 6 ml. 10 to power 6 ml. Okay. Now I know 1 liter will is equals to 10 to power 3 ml, or you can say 1 liter is nothing but equals to 1000 ml. 1000 ml. So 1 ml will be equals to 10 to power minus 3 liter. 10 to power minus 3 liter. I have just taken this 1000 in the in the denominator of this one. So I got 10 to power minus 3 liter. So how much 10 to power 6 ml? 10 to power 6 ml will be equals to 10 to power minus 3 multiplied by 10 to power 6. So that comes out to be 10 to power 3 liter. So we got 10 to power 3 liter over here. So that's how we can solve the question. We can easily calculate one thing into the another thing. I hope you have understand. I hope you have understood this thing. There is a lot of mosquito in my house, in my room. They are biting me over here. So mass and weight we will do in the next class. From this class, this is sufficient. I think you have to do some practice for that from your NCERT notebook. You have to do some practice, guys. So if you like my lectures, please like it, like the video. Please share and subscribe also. If you are like thinking of taking the subscription, guys, then you can use my code, that is KJEN code, for getting 10% discount on the Unacademy. You can use my code KJEN code for getting 10% discount. And guys, you can also tell your friends that we have started with the mole concept. We have started with the mole concept. And if you know Hindi, then you can also ask your doubts. You can also ask your doubt in Hindi. I will answer you in the Hindi also. But guys, come live, because if you come live, then you can understand many things that you have not understood anywhere, because this is the first lecture and I am covering everything. I will do every question of NCERT, as well as I will give you practice questions for your JEE exam. So guys, be regular, be on time. Monday, Wednesday, Friday, be on time. And one thing, this Wednesday we don't have a class. The Wednesday class is shifted to the Sunday. So we have Monday, Friday and Sunday class in this week. But from the next week, we will be having the class on Monday, Wednesday and Friday. So remember my schedule. At 10 p.m. I come live. Okay. So bye bye guys. Thank you so much.